It would be helpful if I turned the mic on. But nobody was having problems hearing me. Why is that?
Good.
Okay, so we're going to start over from, no, we're not going to start over from the beginning. I guess the poor people who have to watch the video are going to get the subpar experience. I'm so sorry. So we will have, you'll have all the links, so you don't need to try to write them down during the presentation or hold your camera phone up and take pictures of the slides. You'll have all of those links available to you. And I just want to show briefly how you might play with these scripts if you want to play while I'm talking, or if you want to do it later when you return back to your terrible, boring existence in your real job, far, far away from I did it again, MacAdmins summer camp. So I'm going to switch over quick to the Finder. So if you downloaded the folder from GitHub, I'm going to just demonstrate. I'm going to drag it onto. Why is it not dragging? I'm going to not do that. I'm going to drag it onto TextMate. There it goes again. Wow. All right. Maybe I need a mouse. See, look how it like starts and then it snaps back. Ah, heck with it. We'll do it the other way. Yeah. So go to desktop. So we're going to open the entire folder. So if you've got a text editor like TextMate or BBEdit or Sublime Text, I mean, one of the really nice things is being able to have an entire folder of files open, and then you can just browse through and pick whatever file you want to work on, and you can quickly switch back and forth. And one of the nice things about TextMate and why I really like it is it's really easy to run these scripts. There's a bundles menu, and blah, 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 but as it turns out, Command R will run the current script. So I can just hit Command R, I get my result, I can make a change, run it again. And so it's a really fast and easy way to play with the scripts and learn as you go. All right. This is a build as an advanced session. We're talking about PyObjC, so it is assumed that you have some knowledge of Python. If you don't, here are some books you can read. It is a 75-minute session, so let's take about 15 minutes. You can read some of these books, learn about Python. I mean, most of the sessions end early anyway, right? We might as well make productive use of this time. Even if you don't know a lot of Python, hopefully you'll be able to at least understand these examples. Hopefully you'll be motivated enough that, oh, I can do some cool stuff with Python and Python Objective-C, and I want to learn more. Maybe you can check out some of these books. What is PyObjC? It is a bridge. It's a bridge between Python and Cocoa. If you go looking online for some documentation about PyObjC, you almost certainly will run across this page here. Why is the documentation so bad? And the person says, I just want to create simple Python applications with Cocoa GUIs. What is this NS thread detach new thread selector to target? What does this mean? This documentation is terrible. Well, he's not wrong, but all the PyObjC documentation does is document PyObjC. But as I said, it's a bridge between Python and Cocoa. It makes no attempt to document Python. It makes no attempt to document Cocoa. And so one of the responders was right on in that he tells you that in order to really make any sort of productive use, you have to learn at least a little bit of Objective-C so that you can actually integrate the two things. That you're not going to be able to get by knowing nothing at all. But I like to call PyObjC sort of a training wheels introduction to the Cocoa frameworks, because Python is a far more friendly language, far more forgiving language for people than is Objective-C. You don't have to worry about pointers, you don't have to worry about memory management as much. Python takes care of those details for you. And so it's kind of a friendlier way to learn some of Apple's frameworks. So you're going to need to know some Python. You're going to need to know at least a little bit of Objective-C, at least enough to be able to read Apple's documentation on its frameworks. And when you go back home and you're saying, I really want to learn even more about Objective-C because, wow, it's the neatest language ever, There's some books. I do find Apple's online documentation really good, but there are definitely classes and books out there for learning more about Objective-C and Cocoa. PyObjC is really used a lot in the MacAdmin community. Magervelp, also known as Per Olofsson from the University of Gothenburg in Sweden, uses it in login log and auto damage. Who uses auto damage? Who doesn't use auto damage but's heard of auto damage? All right, good. Graham Gilbert uses it for his Imager application, which is, if you're not familiar with that, it's sort of it's an open source replacement, well, analog for Deploy Studio that does not require a Mac in the server room. You might be surprised to find out that Monkey makes use of PyObjC. PyObjC lets your code call code inside Apple's frameworks. And typically those have been, so far, written in Objective-C. And the bridge is two-way. There might be a function in AppKit that needs to tell you that the user has clicked a button. And in order to do that, it needs to call code you've written. So you can use the PyObjC bridge to cause AppKit methods to call your code that you've written in Python. Python and Objective-C have very, very different syntax. They look very different on paper. And so whenever you want to use a Cocoa method inside your Python script, you have to learn how to translate Apple's documentation for the Objective-C method into legal Python syntax. So we're going to look at sort of the basic ideas of how you do that. So here's an Objective-C method call. We have some object, and we tell it to do something using argument 1 and with additional data in argument 2. Now to convert that to legal Python syntax, we have to get rid of those square brackets around the outside. That's used in Python to mean something else. In Python, to call a method on an object, you use the dot syntax. So we're just going to bring some object down and add a dot after it. And then we bring down the two parts of the method name, the do something and the with additional data, combine them. Python also does not really like colons in function or method names, so we have to convert those to underscores. And finally, we take the two arguments and put them in the parentheses at the end of the function call, separated by commas. So there's a lot of steps there, but it's pretty much the same anytime you see a Cocoa method. Let's look at one that's a little different. Here we have a Cocoa shared workspace object, and we're going to tell it to open a file using the application text edit. So again, we get rid of the square brackets. We say shared workspace dot open file underscore with application underscore, and then bring the two parameters down inside parentheses. So that will cause Python to call the shared workspace object, which is from NSApp, or from AppKit actually, and then open that file using the text edit application. Okay, you've looked at a lot of boring text, so here's my favorite ice cream at Berkeley Creamery, which they have not had in stock the last 2 years. This is the black raspberry ice cream. It's fantastic. For some reason, they have a very large number of vanilla-derived flavors this year at the Berkeley Creamery. Vanilla is a fine, fine flavor, but it cannot hold a candle to black raspberry. Yeah, good. All right. So I want to show a little bit more complex example, and we pulled this straight out of a piece of Apple documentation, the documentation for NSWorkspace. This has a nested set of method calls. So first we have, in the inner set of square brackets, NSWorkspace is being asked to return the shared workspace object. And then from that object, we tell it to open the file using the application text edit. So converting that to Python syntax, again, we just bring that method down and convert it in place by removing the square brackets, inserting the dot, and since it has no parameters, we can just put empty parentheses at the end. There weren't any colons, so I didn't have to put any underscores anywhere for that particular one. And then we can bring down the rest of the method for the next level up, open file underscore with application. And again, we can bring the parameters into the parentheses. You'll notice that in the Objective-C version, there are these @ symbols in front of the strings, and that's an Objective-C-ism that means what follows is a literal string. The @ sign means something else in Python, so we just drop that completely. We don't need that to tell Python that the thing in quotes is a literal string. I want to point out that the rule about converting colons to underscores always holds, even if the method has a single parameter. So here we have shared workspace, launch application, text edit. And when we convert that to Python, we have to make sure that we put that underscore there. It's really common. I do it all the time when converting them to forget to do that. It's easier when you're doing multiple ones because the underscores kind of break up the sentence in a way, and you forget to do it when it's just a single parameter. It won't work without that. One more example. So many functions, you're going to work with file names a lot, but many of the functions in Apple's Cocoa frameworks, they don't want file names, they want NSURL file URLs. And so you have to take a file path that you have, convert it to an NSURL, and then you can pass that NSURL to some other Cocoa function that you might be using. So we can take a look in Apple's documentation and look around for a function that might do what we need to do, convert a file path into a file URL. So does anybody notice a problem here? Apple's documentation, I knew Frogger would notice the problem. Apple's documentation by default is going to show you Swift. Now I know Swift is great, it's the future, Joel Rennick loves it, blah, 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 blah. But we're working with PyObjC and not PySwift. So we want to look for the Objective-C version of the documentation. There's a little pop-up menu. Apple keeps moving around where that control is on their documentation. Right now, it's a little pop-up menu, and you can switch over to the Objective-C version of the documentation. If you start with the Swift version of the function call and try to convert that to Python, it's probably not going to work. So make sure you start with the Objective-C version. Well, this function's looking kind of like what we need. It's going to create a file URL given a path. And we can see the definition down below there. The path is a string that's being passed to it. So we look and we see, okay, this is in NSURL, which happens to be in the Foundation framework. So to get started, in Python, we would import NSURL from Foundation. And then we use the conversion rules that we talked about to convert that file URL with path call into Python syntax. And that's the very first example script in the downloaded examples if you downloaded them. If we run that, we get a file URL. Yay. Let's try another method that just adds just a tiny bit more complexity. This one is file URL with path is directory. So it takes one more parameter, a Boolean, that is a hint to the routine whether what you've passed it is a directory. So we start the same way. We import NSURL from Foundation. And we use the conversion rules that we talked about. So now we've got underscores separating file URL with path and is directory. We pass the path and true, because we're going to say that this is a directory. And when we run it, wow, look at the amazing difference. We have a trailing slash, so now we know that we're dealing with a directory. Okay, that was boring. So here's some Peachy Pertuno. Let's look at some more advanced conversion rules. And this gets a little tricky, and it's okay if you don't understand it at first, but you will eventually run into this issue, and then you maybe somewhere in the back of your head be like, I remember Greg talking about that. Oh well. But maybe it will help you in the future. Very often on the MacAdmins Slack, on various mailing lists, in person, people will ask, how do I get the the name of the current logged in user. And there's lots of ways to do it. People will use the who command or find out who owns the console file. But Apple has a recommendation. This is a technical Q&A, and someone's asked, how do I tell whether a console user is currently logged in? And they give you some recommendations, and they recommend that you call the SC Dynamic Store Copy Console User function from the System Configuration Framework, and they even give you some sample code in C. And here's that code, made it bigger, and we notice in that first comment there that it returns the name of the current console user. Well, that's exactly what we were looking for. We've been asked, how do I find out the name of the person who is currently logged into the GUI? So this looks good. And there's the call that seems to do it. So result looks like it's going to have the name of the console user. And that doesn't look too difficult to translate into Python. So looking back at the documentation, we see it's in the System Configuration Framework. So, and it returns a string. And let's see. The first parameter is an SC Dynamic Store ref. What the heck is that? Well, we have a fun little escape hatch here. We don't have to pass anything there at all. We can pass null. So that's good. And then for the next two parameters, we can also pass null because all we care about is the name. We don't care about the UID or the GID. Null is Objective-C. To convert that to Python, we're going to use Python's built-in none. So again, to get started, we will import the SC Dynamic Store Copy Console User function from the System Configuration Framework. And we'll use the conversion rules that we came up with to, and you'll notice there isn't really much of a conversion here at all because we don't have those brackets, so we don't have the Objective-C method call syntax. We don't have any colons in the function name, so we don't have to convert anything to underscores. And I provided the non-obvious bit of information that you can use none instead of null. So this looks like this might work. Let's try running it, and if it works, we're going to get the name of the current user. Okay, what the heck is that? I mean, there's a name in there, but there's some other stuff there too. That doesn't look like a string. That looks like 3 values, one of which is a string. So something didn't go the way we expected. So we better look at the documentation a little bit more closely. I mean, it does say that it's going to return a string. So if we look down at the return value, we look at that a little bit more closely. Okay, now it says that it returns the name, user ID, and group ID of the user currently logged into the system. Now we look back at the UID parameter, and it's actually not a value we send to the function, it is a pointer. And same thing with GID. So this is a C-ism. This is something, if you're not familiar at all with C or other languages that work at that level, you may not have encountered this. But C functions can only return a single value. So that's the string that's going to contain our username. But there's a pattern you will see, especially in Apple's use of C, to return additional values by passing pointers. So in this particular function, we basically say, here I've got an empty bucket, I've got 2 empty buckets, go fill them with something. And so that's what you're actually passing is the location of that empty bucket so that the function can put the UID and the GID value in those buckets. Python doesn't deal with memory pointers. So when we convert this type of function call to Python, we have to do it a little differently than we've done so far. So in sample code, you might see something that looks like this. You'll see that ampersand in front of the name of the variable, and that indicates that it's a pointer. We're not passing the value of the UID, the value of the GID, we're passing the actual address to that bucket. Python doesn't do that. Instead, for Python, we just put nothing there. We just pass none for those, and the PyObjC bridge handles that for us magically. We don't have to think about it, and it just returns those values directly as part of the return. Because Python can return multiple values from a function. So instead of having to do this pointer arithmetic and and worry about that sort of thing. Python handles it for you, or at least the PyObjC handles it for you, and you get those values back directly. So pass none, we get that stuff. So that now explains why we got this back instead of just a simple string. So now that we know that, we can fix our script. And since we know we're going to get back the name, UID, and GID, we explicitly do that in our script, and we can print it, and now we get something useful. My UID is not really 1, 2, 3, 4. When I was doing these slides, I had my actual UID there, my actual GID there, and my boss is like, actually my boss's boss, he had to review my slides, like, oh, you don't want to put your actual UID there. Really? What? Are you going to be able to attack me because you know my UID? I don't know. Well, my boss's boss is very cautious about that sort of thing. All right, that was dry, boring. Let's talk about the hackathon a little bit. I have an entry, or at least I had an entry for the hackathon. I live in the LA area. My family and I are big Lakers fans. We go to games every once in a while. This year during the off-season, the Lakers had the #2 draft pick, and they picked Lonzo Ball, who is a standout freshman from UCLA. And right now, going on is the NBA Summer League. And this is usually rookies or second-year players playing, and it's highly anticipated, at least for Lakers fans, because it's really our first chance to see Lonzo Ball in the Laker uniform and get an idea how he's going to play. So last night I'm in the hacker room, the hackathon room, and I realize, I get this text alert, and I realize that one of the Lakers Summer League games is going on as I'm sitting in there. And I have a phone, and it has the Watch ESPN app, so load it up, and amazingly enough, even with the Wi-Fi here, it was able to get a pretty decent stream of the game. So I'm holding the phone, and I'm watching the game, and it gets really boring and tiring to hold the phone for a long time, because a game's not a 5-minute YouTube video. It's hours long. And so this is a hackathon, and I need to hack something, and the true meaning of hack is that you've got to work with what you have. It'd be no fair if I jumped in a car and went down to Best Buy and bought something. I had to look around, and there was a cup, and there was a knife, and I was able then to use that, and I was to hack that cup into this thing right here. And ta-da! I had an iPhone stand, and I could watch the rest of the game without having to hold my phone. So that is my hackathon entry. Please write in vote if I'm not in the official list. Just Greg's amazing hack. There's a hack. Otherwise, I guess we'll just go get some more ice cream. It's the, what is that? Oh, that's the chocolate chip cookie dough. It is good. All right. So what we're interested in doing with PyObjC is using Apple's frameworks. And not every single macOS framework is supported out of the box, but most of the ones you will use are. And if you're interested in finding out exactly which ones are supported out of the box, hi, Joel. You missed all of the negative comments I made about you earlier, but if you take a look at this folder, you will see all the frameworks that are supported out of the box. And it turns out that you can actually use stuff that isn't supported out of the box. You just need to do some additional work. Frogger last night was getting Python to talk to the core Bluetooth framework, and that's not in here, but Frogger's smarter than most of us, and so it was really easy for him. But sometimes he shares his knowledge, and then we can learn from that.
The gist is up now.
Yeah, I'm sure it is, and we'll never find it ever again. So we looked at how you translate Objective-C method calls and Objective-C function calls into Python. There's another bit that I kind of glossed over that we should talk about briefly, and that is the actual types of the variables that get passed around. So Foundation defines certain variable types. There's NSString, NSNumber, NSData, that sort of thing. And the nice thing is that the PyObjC bridge sort of magically, automatically translates those back and forth between their equivalent Python types. So this isn't an exhaustive list, but it kind of gives you an idea that anytime a function needs an NS number, you can use one of the Python number types, and a string gets translated quite seamlessly to Python strings, usually to Unicode strings. NS dictionary, dict, pretty obvious what's going on here. NS data is a buffer, that's maybe not as obvious. And we already saw we could use none instead of null in Objective-C. So maybe we can now start looking at some possibly useful examples to use in your day-to-day work. And we'll start with the foundation framework. And buried inside there are some functions that might return some interesting or useful data here. And we can call those, they're very easy to translate, so we can call those from just by importing foundation and then calling each of those functions, NS username, NS home directory, NS temporary directory. And so we get kind of what we expected there. So that's not that interesting because a lot of that information you can get pretty easily from Python without having to call Objective-C. But you know, if you're just getting started, start simple, try something easy, make sure it works before you move into the trickier stuff. So we're going to move into the trickier stuff. So let's look at some stuff in CoreFoundation, specifically CF preferences. And I think probably this is one of the #1 tasks people do, especially with scripting, is they're managing something about the machine, they're managing something about software installed on the machine, and that often means altering, setting, or managing preferences for those applications or for the OS overall. And down in the various layers of Mac OS, down close to the lizard brain level, are the CF preferences utilities. And these are a set of low-level functions for reading and writing preference values. And we can use them by importing CoreFoundation. And in this example here, which is also available in the downloads, in this example here, we're simply reading the value of show hard drives on desktop from Finder's preferences. Now, you notice this is really similar to the defaults command, but there's something different about it that messes me up every time, and that is the order of the parameters. So in defaults, you provide the preferences domain first, and then the key. More general, more specific. That's logical to me. CF preferences, copy app value, does it exactly the opposite way. There was a long-standing bug in Monkey because those two values were swapped. Nobody ever reported it. I noticed it like 3 or 4 years after I'd written the code. Like, oop, better fix that. So nobody, that actually probably means nobody was using Monkey at all. People that come up and tell me that they are, they're lying. Exactly. So you're thinking, okay, so Greg was able to read it. Wow, it came back with true. Boy, that's pretty underwhelming. It's much easier to do with the defaults command. I mean, look at that. It's just a single line. I do that. I'm going to get back the exact same value. Well, it's not really the exact same value now, is it? It's close. But let's look a little bit more closely and see what's going on here. So in this sample script, we're going to use subprocess to call defaults, read back what it returns, and we're going to print a representation of what it returns and its value, and its type. And we're then going to do the same thing with CF preferences. And again, we're going to print a representation of the value and the type that is returned. And if we run that, we find that defaults return a string. And the string is 1 and a carriage return, whereas CF preferences returned a Boolean, true. So you think, well, that's not that big a deal. I can convert that 1 to a Boolean value, not a big deal. So that's not hard. But what if the value returned from the preference is far more complex? Let's say in the Finder preferences, there's this thing called standard view settings. And let's look at that from reading it from defaults and reading it from CF preferences copy app value. So first we're going to call defaults like we did before. And we're just going to print back the type and then the actual value that's returned. And then we're going to use the CF preferences function. We're going to print the type, and then we're going to get fancy. Since I know what's going to come back as a dictionary, I can use Python's dictionary syntax to find a sub-value buried deep inside what is returned. So let's run that. So first we run defaults, and we get a string back, and the string is really long. I've cut the middle of it, I snipped it out, and it's complex. It's got lots of stuff buried in it. So if you wanted to know, say, is the extended list view settings calculate all sizes, what's the value of that, you're going to have to figure out how to parse this string. You could probably use grep and cut and awk and all that stuff and maybe narrow in on what you want to do. But that's a lot of trial and error, and you've got to do it right. On the other hand, if we use the CF preferences method, we get back something that we can use as a dictionary. So it's the NSCF dictionary, which gets translated by the PyObjC bridge to be something that we can use as a Python dictionary. And then we can use the Python dictionary syntax to narrow down to that extended list view settings, calculate all sizes, and we can get that value back. So if you're dealing with anything reasonably complex, you really should be using these methods rather than trying to parse the output of the defaults command. We can also use CF preferences to write preferences. So this is just an example of using CF preferences. Let's go back. CF preferences set app value to show the hard drives, to set that to false, so we could turn that off. All right. And one more thing, or one more reason why you might want to learn about the CF preferences utilities and to use them is you very often probably want to query a machine and find out what's been set. Maybe you have to find out, maybe it's required that the ask for password is turned on for the screensaver for all your machines. So I'll use defaults read com.apple.screensaver ask for password, comes back with a string of 0, which I've now since figured out that means no or false. So, this machine isn't asking for a password when the screensaver comes on. So let's double check that in the security and privacy preferences pane. There's a disconnect here. The preferences pane is telling me that the ask for password is set. What's going on? Anybody have any ideas there? Why is it different? Elliot. Profile. Elliot said profile, and he's right. This preference is being managed by a profile. Well, defaults doesn't care about profiles. Defaults doesn't know anything about them. It only reads the value of the preference as it sits in your home directory. On the other hand, if we use that CoreFoundation CF preferences copy app value, it gives us the effective preference. It knows about the various levels of preferences, including managed preferences, which are at the top, and it will give us what that effective value is. There's also a function that lets us ask, hey, is that value managed? Is it forced? Is it managed always? So if we run this script, here I show you first we're going to get the effective preference, and then we're going to find out if it's forced. We run that. We now find that the effective preference is yes, the ask for password is true for the screensaver, and it is managed. So that is way more useful information to have than what we got back from defaults, which was 1, wrong, and 2, didn't tell us whether the thing was managed or not. Okay, so I complained that there wasn't any black raspberry ice cream in the last 2 years. This is actually a photo from last year. This is the black raspberry frozen yogurt. It's good. It's not as good as black raspberry ice cream.
So they waste all the raspberries.
Yeah, I really think that there should be a law. If they only have a limited number of black raspberries, we got to prioritize the ice cream.
Petition.org.
Okay. Good. See? All right. Let's look at another framework. Let's look at AppKit. There's a lot of fun stuff in there, lots and lots of stuff. We're going to look at a really tiny part. We're going to look at NSWorkspace, which is a class that lets us do some things like you would do in the Finder, stuff like open and manipulate files, launch applications, open documents, that sort of thing. So we could, from AppKit, which is where this NSWorkspace is defined, we can import that. All the sample code shows us that we have to get the shared workspace from NSWorkspace, and then we can do stuff with that shared workspace object. So we import workspace, we get the shared workspace, and then we're going to ask it to find and print us the full path for the application Microsoft Word. Notice we didn't give it a path. We didn't say Microsoft Word.app. We just said, hey, can you find an app out there somewhere called Microsoft Word? And then, I'm being very, I'm assuming that I am going to find it because I'm actually going to ask it to launch that app. So let's run that, and it comes back with, oh, I did find Microsoft Word. It's in your applications folder. And bing, oh, look, it launches Microsoft Word for us. We can do some other things. We can ask the workspace object for a list of running applications. So we run that. That's not what we expected. That's kind of weird. What is that? It is a list of NS running application objects. So now we got to find out what those are. We can go to the documentation for NS running application. And we find out that it's another type of object that has a lot of functions that can be called. And we can get additional information about any of those applications. We see we've got localized name. We can get the icon for the application. Launch date, that could be interesting to find out when it was launched. But for this example, we're just going to go through the list of running applications, and we're going to print its localized name. Localized name means the name for the current language. So we're going to see it in English, but if we were running this and my machine was set to German, we would see the names of the applications in German. So when we run that, we get back a list of the currently running applications in English. We can narrow down on a single application and get a bunch of information on it. So this time I'm going to go through the list of running apps, and I'm going to look for one that has the bundle identifier com.apple.terminal, so the terminal application, print its name, its URL, the URL to the bundle, which will be a file URL, so we'll know where it is on disk, launch date, and is it currently hidden. And I run that, it finds it, it's the terminal, there's where it is on disk. It was launched on the 13th, so it's been running for a day or so, and it is not currently hidden. We can even interact a little bit with these applications. In this case, we're going to bring an application to the front. So again, we're going to loop through the list of running applications looking for one with the Finder's bundle identifier, and then we're going to send a message to it telling it to activate and to ignore all the other apps, so that will force it to come to the front. So if we run it, the Finder comes to the front. This is a fun example as well. We can use AppKit objects and methods to change the desktop picture. Well, in this case, we're going to change it to a random picture. And we're going to import the standard Python glob and random modules and a few bits from AppKit and Foundation. So glob and random come with most, maybe all, distributions of Python. And again, AppKit and Foundation are specific to PyObjC. So we start by getting a list of all of the JPEG files in the library desktop pictures folder. That's what glob does for us. Was it Shay Craig was really loved glob. He liked to say it at random. But that works like in the shell. You know, if you type ls library desktop pictures star JPEG, it would give you a list of all of the JPEG files. Exact same concept here. It's going to give us a list of file names that are all the JPEG files in that folder. Then the random choice function just picks one of those at random. So we get a list of all the JPEGs, pick one at random. But what we're getting back is file paths, And what the functions that we want to use want are NSURLs. So we looked at this before, but we're going to use NSURL file URL with path to convert the picture path into a file URL. Once again, we have to get that shared workspace. And then this is new. We're going to ask NSScreen to give us a list of all the screens. Well, I have 2. Who has 3? You're crazy. Who has more than 2? More than 3? Do you have 4 screens? More than 4 screens? Yeah, on the same computer, I assume. Yeah, wow. So, but it would iterate through all the screens, or monitors in this case, and it will set the desktop picture for that screen to whatever this random thing that we did. So that's kind of hard to show in here, so let's just demonstrate that. So we're going to go to the app kit, this one here. So again, we're getting the random pictures, and so I'm going to move this down so you can see the desktop. There's Moana sailing to her destiny. And I'm going to run this. Again, I can just hit Command-R to run this script. And unfortunately, the result window comes up in front. And so it changed the desktop. Let's run it again. Listen to the rain. Isn't that lovely? Yeah, I clicked the wrong script. That's nice. There we go. And it changes. And changes. I don't like that one. Let's keep going until we get one I can handle. Oh, definitely not that one. Okay, well, that'll work. That'll work. So push that script out to all your users. Just change their desktops at random all the time. They will not mind at all. I mean, thank you for providing this service to us, you wonderful IT folk. All right. All right, let's do something even a little bit more interesting, fun. Let's look at Notification Center. This is relatively new to the macOS, although it's been around now since 10.8, so I guess it's not that new anymore. And this is the thing that lets you, it pops up a little notification in the upper right corner that's a little bit less obnoxious way to notify users of stuff. Apple has a lot of documentation on it. It's really hard to read and understand. You know, I'm sure the people who wrote it think it's wonderful. I think it's nearly impenetrable. But I've hit my head against the desk long enough, and so I've given you some sample scripts you can start with anyway. And maybe you'll find out stuff about how this works that I haven't figured out, because there's still mysteries to me. But we have some scripts in the demos. So we'll just do a really simple one to start. And this is kind of the bare minimum to display a notification. We create a notification, and we set a title, a subtitle, and some informative text. We get the default user notification center. I don't know how you get any other user notification center other than default, or why you would, but that's what you do. You just follow what Apple tells you to do. And then we tell that notification center to deliver the notification. And I put that all inside a Python function called notify. So I can call that function and change what I pass to it. And if I run that, I get a little notification up in the screen there. And so there's this stupid, weird rocket ship icon. And you know, if I would think that if you did that to a user, they might be a little scared. You know, what's going to blow up? Why is there a rocket ship on my screen? I've never launched an application with a lock. It turns out this is actually the Python application, and that Notification Center always displays the icon of the application that called it. So by default, it's going to show the icon for the Python app, which is this goofy rocket ship. And there really isn't an API to tell it to display a different icon. It's just going to display the icon of the current app. So you might not want to do that. You may want to do something else. Well, it turns out you have to do a little bit of a hack, and I'll give all the credit to Frogger for this. He found out that you could sort of on the fly lie and overwrite the bundle identifier of the current application to be whatever you want it to be. So what we do, there's other ways to hack at this, but this one's pretty interesting. I'm sure it is. I would love to see that. I suspect it actually isn't, because I've also seen how you do it in Objective-C, and it's a big ugly hack there as well. Yeah, it's not easy. Actually, I think it's easier in Python than it is in Objective-C, but that's my opinion there. So what we actually do this time is we're going to pass a bundle ID to our notify function, and then we're going to set that fake bundle ID. So instead of being org.python.whatever, we're going to set it to something else. And then for this demo, we're going to set it to the bundle ID of Managed Software Center. So when I run it, now I get the icon that users expect. Now there's still a problem here. Now if you click on that notification, absolutely nothing happens. So we got a notification, but it doesn't do anything. It goes away if we swipe over, but it doesn't do anything useful. So we need to write even more code to do that. In order to be notified that the user clicked on the notification, the notification center code has to call some code of yours. So this is where that two-way bridge comes into play, where the Apple framework is calling back into code you wrote. So we have to write a notification center delegate. And you're looking at this and go, how would I know that? Well, if you plow through the Apple documentation on Notification Center, you will see some examples of this written in Objective-C, and I've translated them into Python. And anytime you write a delegate, a COCO delegate, almost always you're going to be creating a class that inherits from NSObject, and then you have to implement certain functions or certain methods that they tell you are required for the delegate. In this case, the big one we need is this user notification center did activate notification. That's what the framework is going to call in your code to tell you, hey, the user clicked on your notification. And once we get that message, we're going to launch the app. So I just added an additional function to this thing where, since we're dealing with bundle IDs anyway, let's use that bundle ID to launch the app. Yes, we should really use the NSWorkspace functions that I was showing you earlier. I'm going to be lazy and just call open. So we create our delegate object. And after we deliver our notification, we have to keep running. So there has to be something running for it to tell us that it clicked. If we were to just send the notification and then quit, it would tell nothing that exists. It wouldn't be able to tell us that it had clicked. So let's do that after a short brief look at Alumni Swirl. But we're going to do it live because it's much more interesting that way. We'll see what fails horribly. I'm actually going to walk through all 4 of these notification centers so you can just see sort of the progression here. So again, this is the very simple one where we're not doing any hacking at the bundle. And so when we run it, we get the software update available, but with the Python icon. I can make that go away. And then we added the Frogger hack where we set the bundle ID to Managed Software Center. We run that, and if I click it or I click show, really nothing useful happens. So then we added this notification center delegate, and we keep running until that notification center delegate gets some sort of information. So now when I run it, I get this, I click, oh look, Managed Software Center is launching, so yay. Okay, but didn't show us our updates. It just went to that screen. So we can add even more code. That's always the answer, add more code. We can, when the notification is created, we can attach an action to it in the user info parameter. You can that's just arbitrary data that you can put in this user info, and that gets sent back to you when the user clicks. And we're going to just put some stuff in there to tell it to open a URL. And it turns out that you can open a Managed Software Center to a specific view by using a URL, so that's what we're going to do. So when they click it, we're going to handle the notification center or notification user info, which we're just going to get the information from that open URL thing and open that URL. If we don't have a user info, we'll just open the app. But if we do have a URL, we'll open the URL. So what we send to the function now is not only the bundle ID of the app, but also what URL should be opened when the user clicks on it. So let's run that. Again, we get a notification, and now if I click details, Managed Software Center opens, and it should go right to the updates page. I don't have any pending updates right now, so in other words, that notification was lying. I don't have any pending updates, but if I did, you would see them here in the Managed Software Center list. All right. So I mentioned that you can use things that aren't out of the box supported by PyObjC. And with the new Touch Bar MacBook Pros, we also have a Touch ID sensor. And that is a new bit of code in the OS that is not yet natively supported by the PyObjC that is shipping in OS 10. But the guy who developed PyObjC, if you go to the official PyObjC website, he's already written the bindings to get PyObjC to work with the local authentication framework, which is what we need to work with the Touch ID sensor. So I just copied that from his website, dropped it in this folder, this local authentication folder, and I don't even have to even know what it does. In fact, if you look at it, it's like, what is this mystery stuff? It's just lots of double underscores everywhere, doing magic methods everywhere, and I really don't understand it, but I'm sure Frogger's looking at it going, I could do that better. But that's fine. We always want to stand on the shoulders of people who know more than us. So what I'm going to do here is I just took Apple's sample code for working with local authentication, translated it to Python as best I could. And what it allows us to do is ask the user to authenticate. They can either authenticate by typing their password, or they can use Touch ID. Now, in order for you to see what's happening on the touch bar, I'm going to use an app called Touche, which I should spell correctly. And it basically mirrors what's happening on my touch bar up on the screen. So you can see what I'm doing here. So I'm going to run this local auth app, which is going to ask me to authenticate. And the reason that I provide is to prevent all your files from being erased. So I'm going to run that. I run that. And so I get this dialog. Python is trying to prevent all your files from being erased. Touch ID or enter your password to allow this. And you can see on the touch bar, I'm getting this little, you better touch ID to prevent your files from being erased. And so I'm going to touch with the wrong finger. I don't, uh-oh. I'm going to touch with the wrong finger. Uh-oh. Now I'll touch with the correct finger. Yay! So I think that's another one you could just push out to all your users. They'll enjoy a good joke. It's a good joke.
You spoofed bundle ID or whatever the thing says Python is.
Probably. I haven't dug in very deep to do that. Yeah. No, actually, I don't want to go back to this. We've got a couple more fun little demos here. We'll make that go away. We don't need Touche anymore. Let's go back. There we go. So a couple more things, kind of fun. Again, Frogger, but then since he's not consistent, in this context, he calls himself Pudquick. So you need the Mike Lynn to different things mapping app. I'm sure it'll be available on the App Store at some point. You can carry around your phone. Okay. But On GitHub, he calls himself Pudquick. All right? But someone asked him how you could, in Python, we could lock the screen instantly. So maybe you could make a hotkey or an icon on the dock or something to lock the screen. It's the same thing that you do if you put the keychain menu item where you can lock the screen instantly, but that's kind of clunky. It'd be nice if you had something that just said lock screen. Actually, with the touch bar Macs, you can put that on your touch bar to instantly lock your screen. And I find I'm such an awful typer that I brush the touch bar all the time, and I was constantly locking my screen, locking my screen. I did not like it. So that went goodbye. I saw why Siri is not on my touch bar either. But anyway, so if we run this script, oh, I also like to point out, you notice that it is calling a private framework. So if you were at Frogger's session yesterday about reverse engineering the OS, and he talked about calling private frameworks. So again, this is an example of PyObjC calling something that isn't supported out of the box, but he loads this login framework, which is in private frameworks, and he's kind of reverse engineered the name of the function that he wants to call, and it doesn't return anything, which is what that it doesn't really need anything special. So we can just run it. He's going to call this lock screen immediate. So if we maybe this was we attach this to a menu item or something, and all it does, lock the screen. So I thought that was really interesting, but the problem with a locked screen like this is it looks a lot like an off screen. In other words, a user comes up to this and they don't know if the machine is on or off or whatever. And so for a personal machine, maybe that's fine, but maybe in labs or something like that, you don't want to have people walk into a room full of black screens. So I thought, well, maybe it would be nice to do the same thing, but instead of instantly locking the screen, we'll just turn on the screensaver. Now wait for it to unlock. There we go. So I poked around and I found some sample code for interacting with the screensaver framework, which is not a private framework. It is a public framework, but a lot of the functions are not documented. Apple doesn't document them at all. But they're in there, and there was I found an application out there, open source application out there that dealt with those. So I was able to steal some ideas, and I wrote some code here, and it does some stuff. We're going to use the CF preferences code to make sure that the password is active, because I want it to not only activate the screensaver, but I want to make sure that it's going to require a password to clear the screensaver. So I check that and set it to require a screensaver or require a password if it's not currently set. And then I use some of those secret functions that are inside the screensaver framework to start the current screensaver instantly. So if I run this, screensaver kicks in, and so you know, if you had a folder of informational messages, like in a lab, that would be really great. You can have the tech support number and you know, the 911 equivalent, and you know, whatever stuff that your organization wants to communicate to everyone. It could be on the screens. And then of course, if I try to get into it, I have to authenticate, and I'm back in there. So that's Python just instantly starting up the screensaver for us. I practiced this a lot, and I thought I hit an hour to an hour 10 minutes. I'm talking incredibly fast, and we have 15 minutes here for questions, I think. I've double check before we dip into that. Do want to remind you that there are lots of links included in the download. I'm going to highlight a few of the big ones. The official PyObjC documentation, you want to check that out. Frogger has written so much stuff using Python and PyObjC. If you want to do something tricky and you can't figure it out, if you search his gists, there's a really good chance he's got some sample code that will do something at least along the lines that you want to do. I mean, some of the other interesting ones is he's got some Python code to get the status of the battery on a laptop. That might be something you want to report or check, see if a battery's about to fail or whatever. To set up the machine to auto-discover the time zone Sometimes that, when you're booting a brand new machine, it doesn't like to do that, and this is a way to kind of kick it in gear. Does that also set the location services?
That specific one does not.
Not.
But there are a couple other people who grabbed and ran with that and set up location service and do make sure Wi-Fi is on because it relies on that and all that kind of stuff.
Sure. So, and again, this is all in Python, which is super fun. And then we looked at the locking screen gist. I'd like to also call out a tool he demoed last year at Penn State MacAdmins as part of the hackathon called Nibbler. And it is a tool to create basically dialogues or dialog boxes that you can call from Python. So if you have a Python script and you need to get some information from the user to proceed, you might have used something like Cocoa Dialog in the past or some Apple script. This is a way to do it. You have to create the layout of your dialog box using the interface builder in Xcode, but then you can control that, get information from it using Python. So check that out. And there are more links about building command line tools and even Python applications on MacTech and in some of my blog posts. Again, a lot of this is linked in that document. So with that, thank you for coming, and we've got about 10 minutes for questions if anybody has any. If nobody has any questions, maybe we can do something mischievous with Python, but I will take some suggestions on that. Any questions? Thank you. Yes. The catch box. I'm just gonna walk it over. There's the coffee.
Yeah,
Yeah,
I've already learned that lesson. If I wanted to include some PyObjC that locks a screensaver or launches an app or something like that in a package post-install, which, as you know, runs in root context, does that work? And if not, is there a way to make it work?
So repeat again what specifically you're trying to do in that root context.
Let's say after my Dropbox my Dropbox package is installed, in the post-install script, I want to launch the Dropbox app, hypothetically.
Well, number one, I'd say don't. But if you had to for some reason, it might work in the root context, but the correct way to do it, and you can do this in Python, is first change from root to the current. So you'd get the name the name and or UID of the current logged in user, and then you could use, there's a OS set UID function, something that basically demotes the process from root to that user's context, and then you could run that code. You would do that at the very end, because once you demote yourself from root, you can't re-promote yourself back to root. But yes, you could do the stuff in that context.
There's a way to do that in Bash with launch control, or there is a way, but it's deprecated, still works. It's not super reliable, though. Is the PyObjC way of demotion pretty reliable?
I actually don't know. It's worked for the really minor things I've used it for. I would say Apple probably would say don't count on that always working, because it feels to me like Apple tries with each OS release to really, really separate that stuff out and make it very hard for one process to act as another user. So that actually comes back to my original comment, which is don't do that. But if you have to for some reason, that method might solve your problem. Any other questions? Come on. We can talk about ice cream.
I got one.
Okay, Frogger has a question.
Did you get to see my Hack Week project demo this time?
Did I get to see your Hack Week demo project this time? No, because when they called for the Hack Week demo at breakfast this morning, nobody was there.
Yeah, I showed up later. It was a little bit later.
Yeah.
But
So
you weren't in the
maybe
room?
You can show me later what.
Well,
what you
it's
did.
actually relatively appropriate, and it would
Oh,
actually
do you want to
function
show
right
it?
here.
Do you want to show it here?
Come
Come on, because I know what you were working on. I didn't know if you were actually getting it to work.
Oh yeah.
So, so if I recall correctly, this is using PyObjC.
Yes.
Yes, because you're calling the you're using the core Bluetooth framework.
Yeah.
So, no, bring the catch box so you can describe what you're doing.
Thank you.
Do you need some video?
You could do video, but
I don't think it really matters, right?
it does. I can aim the laptop and everyone can see it. Yeah, but then the camera can't.
Eh.
Well,
Is there another mic pack up here?
I could just talk into the camera.
I don't see one. Look, stereo.
We can switch the thing if you want.
Yep. How about this? Will probably drive the video engineers absolutely insane. But here we go.
Right on top of Greg. That's
Yeah, whatever.
Wakey wakey, you coming back?
Yeah, well, eventually, right there.
all right. So yeah.
So yeah, this is it's written in PyObjC, as was mentioned earlier. It actually incorporates the lock screen function that you were showing just recently on here. And so my Hack Week project, Tim Perfit, Two Canoes, he currently has these little Bluetooth beacons that he's trying to figure out what could people do with. They are momentary push button beacons, and it's hard, it won't show up on video here, but when I push it, there's a little blue light that comes on. The beacon basically advertises itself for 4 seconds and then turns itself back off. And so the core Bluetooth function, which Apple has documentation about how to use it, I was going through it last night, lets you monitor for beacons. So here's the PyObjC. Let's see if I got my sound turned on here.
Well.
Oh, it's going to be through. Oh, you know what?
No, we got it. We got it.
Okay. Well, I just got to set my output device intervals. Do I have? Hold on. Make sure I thought I had the thing where. Okay, good. Okay, cool. So we're going to run this guy. Oops. Not CD.
Don't CD it. Run it.
Yeah. Hold on, I need 2 hands here.
So your fancy script is named untitled.py?
So, well, I'm still looking for a name for the project.
Oh, okay. All right.
All right, so that guy's running right now. So when I click the, yeah, and so if I wake my screen back up here, and so it's locked, and then it has an alternate mode where it actually detects if the screen is already locked when you click the button. But yeah, this is all done in pure PyObjC. And as he mentioned earlier, the core Bluetooth framework is not one that is currently shipping with definitions in PyObjC. It's on your Mac. But I just threw the gist up on my GitHub, and I threw a link into the PSU Mac channel. And so I basically give a few little lines of instruction and pull it into the framework, and then basically implement Apple's example code in Python.
So when you leave the session, go find Tim Perfit and say, give me a Bluetooth button.
He only had a couple of them, so. But he might have a couple left.
Yeah. Thank you, Frogger. All right. If there are no more questions, last call for questions. Thank you very much. You're almost done. One more session.